that you live with anomalies in general, inconsistencies in general, without trying to eliminate them necessarily. Then this idea, I will speak later about the standard model, and this will be important. Some anomalies there are not enough to overturn the standard model, not yet at least. And I recall also the well-known book by Thomas Kuhn, who said that an anomaly is a violation of the paradigm included expectation that governs normal science. And he emphasizes that anomalies provide the impetus for the paradigm change. Then it's important to take account about anomalies, as surely you know. Last, I would like to mention also Larry Landau, who says that science is fundamentally a problematic solving activity. So, he says, the aim of science would be to maximize the scope of solved empirical problems while minimizing the scope of anomalous and conceptual problems. And I think that since we are minimizing the problems, we are not necessarily eliminating them. Perhaps we do not need to eliminate the anomalies. So perhaps we don't need to avoid anomalies, but need to learn how to live with them, even in our scientific fields. That's the point. The third thing is to emphasize some words which provide the content of the ideas I would like to submit to you. For instance, I emphasize the words violation in the definitions, going against to something, deviation, conflicting, and inconsistent with. This is important. I regard anomalies as noticed inconsistencies. Inconsistency may exist unnoticed by the scientist. When you notice an inconsistent, you get an anomaly. At least this seems to be the standard way of thinking. That is, I will give you some examples. Some areas of fields of knowledge may involve inconsistency, but we are not aware of this inconsistency. When you take account of the inconsistency, then I call them anomalies. That's the point. Then I think that we should distinguish between inconsistencies and anomalies from contradictions. Why? Because a contradiction is something, in my opinion, something logical. In order to speak about contradiction, you need a well-defined language and a well-defined logic. If not, you don't know about what you're speaking, because what's a contradiction? Then if a theory, T, has a well-defined language and an underlying logic encompassing a symbol of negation, oops, sorry, then, and all the logical symbology and so on, then you know the standard definition. A, alpha, and beta are contradictory if and only if beta is equivalent to the negation of alpha. In the logic, if the logic is adjunctive, you can make the conjunction of two sentences, whatever, then you can form the conjunction of alpha and its negation and get a contradiction. This is a contradiction. You need logic to speak about contradiction. If not, you speak generally about inconsistencies, about anomalies, and so on. Then the link between inconsistency and anomaly in contradictions, in my opinion, I guess we need to specify the underlying logic of the theory we are dealing with. Why the fear of contradictions? You know, the standard result is the Scottish contradiction, everything written in the language follows as a consequence. And a logic is paraconsistent if it restricts the explosion principle. I add here in the field of inconsistent, paraconsistent logic, also the inconsistent adaptive logics, which some logicians think they are not strictly paraconsistent, but they avoid also the explosion rule. Then I think that we can consider the adaptive logics, inconsistent adaptive logics within the field of paraconsistent logic in a broad sense. Okay, but while you notice it, inconsistencies may not interfere in the life of the scientist. Only when they overturn the paradigm, they become dangerous, except perhaps for paraconsistencies. Perhaps they can absorb the inconsistency by changing the logic. I recall here a well-known sentence by Wittgenstein, I will mention later too. If a contradiction were actually found in arithmetic, this would show that an arithmetic with such a contradiction can serve us very well. Take care about this quotation. It's very difficult to quote Wittgenstein and to take him in isolation because it's a very, as you know, a very difficult philosophy. But let me try to give you some examples of where inconsistencies appear. For instance, the situation where we are not yet conscious about the existence of anomalies. We have contradictions, we have inconsistencies, but not anomalies yet. In the old infinitesimal calculus by Newton and Leibniz, by Newton and Leibniz, the calculus was, of course, inconsistent. We know today. In the language of the old calculus, take in the present language, is not the way they wrote that things, but we can understand the ideas. Take the parabola here, y equals x squared, and at an infinitesimal increment, supposed not null, then is an increment, delta x. Then y also receives an increment here. Then here I pass the square here, simplify by delta x2 with y, and divide by delta x, getting 2x plus delta x. But Newton reasoned this way. Since delta x is an infinitesimal, it can be dispensed with. Hence, dispensing delta x here, we are making it equals to 0. Then we have the quotient which we will give later the derivative of y related to x. But his is absolutely inconsistent. It's a contradiction here because as an increment distinct from 0, delta x is distinct from 0. When we dispense it, we make it equals to 0. Then we're getting a clear contradiction in the infinitesimal calculus. But in the beginning of the calculus, these contradictions were unnoticed. Then it not cause problems, for instance, for many mathematicians and even physicists would use it, Newton's calculus, Newton-Leibniz calculus, without taking account about the anomalies that existed there. So the infinitesimal calculus was quite useful, even in the presence of these inconsistencies. The infinitesimal, were removed by the introduction of the epsilon delta techniques. But in 1916, Abraham Robinson reintroduced them in non-standard analysis consistently, so to say. Today we have infinitesimals and infinities of different distinct kinds. It's we all know fact in mathematics. But look, even in set theory, before the rise of the paradoxes, there were the theory is clearly contradictory from the point of view of logic. But before the rise of the paradoxes, the theory was involved in consistency, but they not were anomalies yet because they were not conscious. Mathematicians didn't realize that there were inconsistencies or contradictions in set theory. Then Cantor's set theory is, of course, a theory involving inconsistency, and when the paradoxes arise, then they become anomalies. In the solutions, was to axiomatize the set theory. Even in scientific theories, it's not an easy task to eliminate the contradiction. I will mention later the example of the standard model of particle physics. But we can doubt that, because who knows if the standard models is consistent? Who knows if quantum mechanics, Darwin's theory of natural selection, or general relativity, we don't know if these theories are consistent from the logical point of view. I put here syntactically consistent, that is, they do not enable a derivation of two contradictory formulas. We don't know yet. But how to go towards inconsistency? I think that we may acknowledge that there are inconsistencies, but this is one of the solutions, refuse to go to the inconsistency and leaving the consistent part only. This is a strategy used by some scientists in general. This raises a naive and pre-scientific attitude. Someone acknowledges the inconsistencies but ignores them and lives happily. We call this the Zandi way. You'll know later why. Let me explain the case with the Zandi people, which do not go in the, this is a Wittgenstein's term, they do not go to the contradiction. They support the inconsistency, but they not get the contradictions. Let me speak about the Zandi people. These are the Zandi people. Well, the Zandi case, Zandi or Azande, people lived in a region between the rivers Nile and Congo, near the South Sudan, and the 30s, the anthropologist Evans Pritchard studied them and wrote a quite influential book, Witchcraft, Oracles and Magic Among the Azande. In a paper from 1989, Richard Jennings summarized the problem from our point of view, involving the belief in witchcraft among the Azande. This is a reconstruction of Jennings' argument. First, they believe in witchcraft. The witchcraft is caused by a substance in the body of the witch. If I am a witch, I have a substance which makes me to be a witch. Only the witches have a witchcraft substance. Witchcraft substance is always inherited by the same-sex children of a witch. Women to women, and man to man, and so on. The Zande clan is a group of persons related biologically to one another through the male line. Then, if a man A of a clan C is a witch, the standard conclusion is that every man in the clan is a witch. This is interesting because, as reported by Evans Pritchard, the Azande agrees and accepts all the premises, but refuses to accept the conclusion. The Zande case, the Zande do not accept the conclusions. Why not? Well, some people guess that they are paraconsistent. They support the contradiction. I don't believe in this case. To my concern, they do not follow the entire line of reasoning, simply stopping when convenient. If you make a deduction, they stop the deduction in a certain part of the deduction, which are enough to them, and do not follow all the deduction to the bottom. Evans Pritchard says, the Azande do not perceive the contradiction as we perceive, because they have no theoretical interest in the subject. They don't want to go to the contradiction. It's not important to them. So they face inconsistencies. They recognize that there are inconsistencies, but they ignore the contradictions which could arise from them if they follow the whole sequence of deduction. The inconsistencies do not turn anomalies, in my sense, to them. They simply do not go there. They do not go to the contradictions. And of course, this attitude will be problematic if they wish to analyze their belief in Western terms. But why do so? Why to be Western logician? This is interesting because if they detect someone as a witch, then all the clan will be a witch. But they refuse this idea sometimes, saying that that guy which is accused to be a witch is introduced in the clan artificially due to a sin of the mother. The mother had a sin and introduced a son which is not of the same father. They have their ways to deal with the contradictions. But this is an important point to me. They do not go to the contradiction. They are aware of the contradiction, of the inconsistency, but do not turn it then do not turn the contradictions, the inconsistency in a contradiction. Well, another alternative will be we acknowledge the inconsistency, but useful and relevant, so that when you should cases, we are aware of the inconsistency and say they okay, they are inconsistent, but they are fine, they are okay. We need to how there are I think two alternatives. First, one tries to find a new logic for the theory. Surely some form of paraconsistent logic in order to have alpha and not alpha. But the problem is to explain, I will mention later, the sense of the paraconsistent negation. This is a huge problem. Then, the first alternative in order to keep the inconsistency is to change the underlying logic. Either a paraconsistent logic and a inconsistent adaptive logic and so on. The second, Thomas Kuhn said here, that I'll mention the second later. Thomas Kuhn says that anomalies in general do not make the scientist change her theory unless she has another one at her disposal. That is, let's keep with the inconsistency and see what it will result later. This is the first alternative. Then, the first one, we acknowledge the inconsistency, but we turn the inconsistency something we can support by modifying the underlying logic. The second alternative is that we can support the inconsistent things, but do not put them together. What I mean by that? This is typical of Bohr's complementarity principle in quantum mechanics. A complete knowledge, says Bohr, of a certain phenomena of all atomic dimensions requires a description of situations that are inconsistent with one another, but both are relevant. A typical example is the wave-particle duality. But note that never the two aspects of matter are seen together. Either the system behaves as a particle, or it behaves a wave, never both. So we do not go to the conjunction of the two complementary sentences or situations. We have the two things, but we do not have the conjunctions. We develop a logic called the logic of complementarity, where we can deal with this kind of inconsistency. Alpha and beta being complementary in this sense, both are relevant for a certain phenomena, we cannot put them together. Well, this another alternative we could be to suspend the judgment about a certain conjecture, since it's true or its falsity can lead to a contradiction. We don't know. We simply suspend the judgment. Say the true or falsity of Goldbach's conjecture. I took another sentence by Wittgenstein. He says, Professor Hardy, the English mathematician, says, Goldbach's theorem is either true or false, but, says Wittgenstein, we simply say that the road has not been built yet. This is the sense in which I use it to expression, do not go there. They do not go there. We acknowledge the existence of something which could be contradictory, but we suspend the judgment. We do not go to the contradiction. We stop reasoning. We can start in a constructive way, I suppose. He's saying, I don't know if Goldbach theorem is either true or false. We have not written symbols enough in order to know about the answer. It's better to wait for the progress of mathematics. I don't know if this interpretation of Wittgenstein is fair or not, but I think it's a rather constructive approach. Okay, this is a rather constructive approach. Maybe we can support the inconsistencies and avoid undesirable consequences because we have not constructed the road yet. They still did not become anomalies. Otávio, I'm speaking about inconsistencies in general, deviations, conflicts, and so on, but unconscious. They exist in the theory, but they are unconscious for the scientists. For instance, the infinitesimals in the old calculus, in the beginning of the calculus. The Cantorian set theory was inconsistent. But when an inconsistency becomes conscious, you understand that they are inconsistent, then I call them an anomaly. Then they are anomalies. Then you need to find a way to deal with them, either to change the logic or to do something other device. This is the idea. This is rather constructive. That is, to them, if you did not build yet the road, they are not yet anomalies. What could happen if Goldbach's theorem conflicts with that is, if you have a certain theorem of arithmetics and the Goldbach theorem, the proof of it's true or this falsity will go against the theorem already proved, of course you have a problem. But it is not something to be discussed later. Other situations. Bohr's theory of hydrogen atom is seen as inconsistent by some people, but this is disputable. All people think that there is no inconsistency there. The theory assumes that electrons have stable orbits around the nucleus and also obey Maxwell's electrodynamics, according to which the electron should emit energy and collapse into the nucleus. It's a clear inconsistency. But this is a known theory, surpassed already by a more advanced view in terms of probability densities. Then, in this new theory, there is no orbit as a call, but just regions where densities indicate the number of electrons. Tencies, so give us a number which we associate is wrong to say as book standard books say that these regions are the region where it's most probable to find the little things hidden in the shadows. The densities give us integer numbers that we associate to a certain number, but there is no individual orbitals. This is my nature of this draws. My interpretation is that it say two electrons in the first level, the energy level, at least at most 8 electrons in the second level, etc. But we're not putting one by one, Otávio and Giulio and Janeiro. It's impossible to do electrons. We solve the Schrödinger equation and get a certain number. 3, 6, 7, there is no counting process. There is no individuality here. Is a way to interpret. But updated information. That's important. This maybe will change things. It was announced on last Tuesday that the Nobel Prize for Physics was awarded to Pierre Agostini, Ferenc Krause, and Anne Ullier for experimental methods that generate attosecond pulses of light. Flashes that last 1 quintillion of a second. Such fleeting flashes of light open the door to observing the motion of electrons in atoms. This is from the just presented Nobel Prize. The journal Quantum magazine adds that when viewed in such a short flashes, the world slows down. That is, they guess that with such flashes, so quick flashes, maybe they will see electrons in the cloud. I doubt that completely, because I think this is a discourse of standard journals. It's not a scientific claim, but I'm quite curious for that, because I will love if they could see an electron. It will be very, very nice. These are the three guys. Nobel Prize Physics just award. Look, some of the challenges to these three guys. Let us suppose that the Quantum magazine is right and that we can observe an electron. Then let us call to them. Let's call the electron E. First, has E a trajectory inside the atom? Second, once we shift our attention to another electron, E prime, and if we wish to go back to E, can we do it? It means, can we be sure that we shall observe the same electron again? I doubt that. Then I'm curious to know about the results, the consequence of these experiments. I am dubbed concerning the first item, although I'm quite sure that 2 is impossible. The electrons probably will not present distinctive properties. The supposition that an electron has an identity is inconsistent. This is a clear inconsistency with the standard logic, where everything has an identity. We have a logical anomaly inside the classical logic when we try to represent quantum entities under the hypothesis of their possible absolute indistinguishability. Several experiments given last years required the absolute indistinguishability of photons and other things in order to the results can arrive. I have the references if you wish.
But then you mean that the electron does not have identity?
Does not have identity.
Yeah,
yes, has not.
Yeah, not that it has.
Yeah.
Right, because that would be consistent.
Sure. yeah, correct. I will need to correct it. Thanks, Otan. Yeah, you're right. Some alternatives in order to go towards inconsistency. We should acknowledge that inconsistencies are everywhere. The problem arises, in our view, only when they become anomalies, that is, conscious inconsistency. Some people, like the Azan, ignore them, since they do not cause problems to them. They live with them. There are some other or more scientific alternatives. First, we do not join them because they cannot be put together, but are necessary for a full description of phenomena, as in the case of Bohr's complementarity principle. Or we do not join them because we don't know how to do that. Let me exemplify this case with the standard model of particle physics. The standard model of particle physics in the present-day situation is formed by 2 fields: the weak theory linking the electromagnetic and weak forces, and quantum chromodynamics dealing with the strong forces. We still don't know how to join them, creating a great unified theory. The weak theory gauge group is this group, it's not important the details, and the group of the quantum chromodynamics is this one, SU3. People, for instance, Sheldon Lee Glashow wrote several papers about that, are looking for a unified group. They call it the SU5, but there is no consensus about this group until now. As far as I know, perhaps Julio and other people can correct. But depending on what we can do, physicists use either the weak theory or the quantum chromodynamics, depending on the problem they are dealing with. There is no good, there is no joint theory. Then why not? Because we don't know how to join them. It's the same case concerning general relativity and quantum field theory. You use one of them, another of them, but we don't have a unified theory. Then we have anomalies, but we don't know how to do it. It's a different situation. Okay, then the alternatives. We can, of course, rewrite our theory with a different underlying logic which avoids its explosion. However, one should realize that this is a very difficult task concerning empirical science. Try to formalize general relativity or quantum mechanics and so on. It's a very difficult thing. In any case, we need to learn about how to live with inconsistencies and even with anomalies, since you can avoid them only in very restricted fields. Then I propose here, summing up here, a schema. Then, let's revise the ideas. We have inconsistency in a certain field, that is, conflicting things, opinions, results, and so on. Either they are unnoticed or they are noticed. If they are noticed, I call them anomalies. Let's suppose we have anomalies. The first alternative is that they lead to contradictions, which make explicit the logic, and we get a contradiction. What we can do with the contradictions? First alternative, to change the logic. The second one, correct the theory, or change the paradigm in Kuhn's sense, or correct according to Popper's, for instance, alternative proposed Lakatos, and so on, in order to correct the theory. These are the contradictions. Either we correct the theory, or eliminate it, or change the theory, or we change the underlying logic. But we perhaps are more concerned to keep the anomalies. Or three alternatives. First one, following Wittgenstein. We put it, they in standby. I don't know, they are anomalies, but we will wait. Let the science evolve, and we see it will there, then we choose later. The second one, ignore them, as the Azantes do, according to my readings. But another alternative to keep them, but not join them. We do not join them. Either propositally, in Bohr's sense, we keep them separated and do not join them, wave and particle. We keep them both, but do not join them. Or we do not join them because we do not know how to join them, as the standard model cases in other cases. That is, these are the general schema, and that's all. Thank you.